In Lesson 1-1, Variables and Expressions, you will be translating between verbal expressions and algebraic expressions. Before we start, we need to know what an algebraic expression is. Basically, expressions do not have equal signs. 3 plus 5 is an expression. However, to be an algebraic expression, it consists of sums and/or products of numbers and variables. For example, 2x plus 4 is an example of an algebraic expression. Or xy is another example of an algebraic expression. Variables are just symbols used to represent unspecified numbers or values. A term of an expression can be a number, a variable, or a product or quotient of numbers and variables. So if you look back up here at my algebraic expressions, this right here would be an example of a term. This is a term. This is a term. Some more examples could be just like the number 5, or it could be just x, or it could be a product or quotient of numbers and variables, such as 3y or x divided by 7. Those are all examples of terms. The last vocab is power. Power looks like this: x to the nth power. The big number is the base, and the little number that's raised up is called the exponent. Basically, the exponent tells you how many of the base you have multiplied together, such as x to the third power equals x times x times x. In the first example, we're going to take an algebraic expression and change it into a verbal expression. We're going to put it into words. This right here, 3x to the fourth power, could be written as 3 times, you'll have to excuse my writing with the mouse. It's a little bit difficult to do. 3 times x to the fourth power That's one example. You could also say the product of 3 and a number to the number x to the fourth power. The second one, 5z squared plus 16, could be 5 times z to the second power, or 5 times z squared. Plus 16. Another example for that same problem could be the product of 5 and z squared increased by 16. Example 2 has us going the other way. We're given a verbal expression, and we're going to write the algebraic expression that they are talking about. The first one says a number t more than 6. A number t more than 6. If I want something more than 6, that means I'm going to add 6 to it. So I'm going to go ahead and write t plus 6. Or sorry, I'm going to actually write 6 plus t. When I'm using t, I try to make it a cursive t with a little hook so it doesn't get confused with a plus sign. So this right here shows a number t more than 6. You could also, for this one, write t plus 6 because addition is commutative, meaning you can switch the order around and you'll end up with the same thing. The next example is a little bit tricky. 10 less than the product of 7 and f. 10 less means you're going to be subtracting, and product means multiplication. If I want 10 less than the product of 7 and f, I want to take 10 away from the product of 7 and f. So I'm going to start by writing the product of 7 and f, product meaning multiply. Instead of writing 7 times f, I'm going to just write 7f. When they're right next to each other like that, that implies multiplying. Now 10 less than that means to take 10 away. A lot of times students will get these two things reversed because they will just start by putting down a 10 and then a subtraction sign. But if you want 10 less than a number, you're going to take 10 away from it. So you actually have to put this backwards from the order it is in the problem. The last one of that type, 2/3 of the volume V. 2/3 of the volume V. When you see of in math, that leads us to multiply. So if I want 2/3 of the volume V, I'm going to have 2/3 V, or 2/3 times the volume. Our last example. Mr. Martinez orders 250 keychains printed with his athletic team's logo and 500 pencils printed with their web address. Write an algebraic expression to represent the cost. First of all, let's define our variables. Let's have K be the cost of a keychain. And let's have P be the cost of a pencil. Now, if we want to write an algebraic expression to represent the cost, we're going to add together the cost of the keychains plus the pencils. So if he orders 250 keychains at K dollars, it's going to be 250K, or 250 times the cost of a keychain, plus if he's ordering 500 pencils that cost P, it's going to be 500 times P, or the cost of the pencil. 250K plus 500P is the algebraic expression that represents the total cost.